so number 30 is asking us to find, again, how long will it take for some decay to go on with thallium. And it specifically told us which natural decay function to use. We used that back in on number 2 as well, except it was for exponential growth instead of decay. So we've got this right here. I'm just going to fill in the information that we know. It looks like thallium has a half-life of 73.1 hours. So if that's the case, we can say that arbitrarily choose that this n sub 0, the initial amount is 1, which puts the final amount at 0.5. In other words, half of 1. So then we have e to the negative k, and then the half-life is 73.1 hours. So here's the 73.1. All right. Now, to take care of this, to get access to this constant so we can solve for it, we can take the natural log of both sides. So that gives us natural log of 0.5, natural log of e to the negative 73.1k. And so that leaves us with natural log of 0.5 equals negative 73.1k. Divide both sides by negative 73.1 to isolate k. And then we get k is equal to, what is k equal to? Approximately, kind of a small number here, 0.009482. Just leave it in your calculator. Even that I had to round a little bit, so that's not ideal. All right, so now we're ready to apply it to this new situation when we have 1 milligram, same initial amount. You see I used 1 for the initial amount there, and then it decays down to 0.7. So this formula right here we're using again, except that our final amount is going to be 0.7. Our initial amount is 1. We know E, and we have negative, and then our constant, oh boy. Okay, so we've got 0.009482 times time. Okay, so take the natural log of 0.7, take the natural log of all of this, and then we get natural log of 0.7 is equal to negative 0.009482t. Divide by that whole thing. Now, I'm hoping that you have all of this in your calculator, so you really don't have to write this big long number down every single time. You could have just rounded it to 0.01 to represent that value that you have in your calculator, I hope. So I'm thinking that if you did the math correctly, you should end up with the time being approximately 37.6 hours.